Welcome back after the break, guys, and we discussed gradient. Now I've done an actual example just on the slide, but let's quickly have a look on how you're going to do it on your topographical map. Now, as you can see in front of you, you have a topographical map, and what represents height on a topographical map, we already discussed it. Trig beacons, spot heights. There's a spot height. Let's quickly go down. There's a spot height. Contour lines, the brown lines all over the map, and benchmarks. But let's quickly do an example from an actual topographical map. Now you need to keep in mind, topographical map is 1 to 50,000 is the scale. So we use a calculation regarding that 50,000. So if I'm going to ask you, let's go and calculate the gradient from Trig beacon 198 to Trig beacon 196. Now keep in mind, a trig beacon consists of two numbers. The bold italic number is the trig beacon number. It's not the actual altitude. It's 156.6 meters. If you look at trig beacon 196, it's 177.1 centimeters. Now let's quickly continue on the bottom of the page. First of all, know your formula. Gradient equals height over distance. So we need to get the height difference between the two trig beacons. And our first trig beacon is 177.1. We need to get the difference. So what do? We subtract the lowest from the highest. Like I've explained to you just before the break. You've got 15 apples, I've got 25 apples. What's the difference? We need to get the height difference. So 177.1, if you look over here, subtracting the lowest, 156.6, subtracting 156.6. And secondly, we need to go and calculate the distance between the two trig stations. You place your ruler from there up until there. And I get exactly 15 centimeters. Because we express gradient in meters, what do we do with this 15 centimeters? 15 times with 500. If you look at the measurement quickly, from the one trig beacon to another one, you can see it's exactly 15 centimeters from there to there. So now we need to do our calculations. The first one is quite simple. Just subtract the lowest from the highest. Get my calculator out. 177.1 subtracting 156.6, and my correct answer over there is 20.5. We take 15 times 500, that gives me 7,500. Now remember, before the break, we need to get a ratio of 1. To get a ratio of 1 of 150, we divide 150 by 150. Now in this case, we need to get a ratio of 1 because we want to see how many meters do we need to travel for the gradient to increase with a single meter. So we say 20.5 divided by 20.5. Simple math. What you do on the top, you need to do on the bottom. So 20.5 divided by 20.5 gives me 1. 7,500 divided by 20.5 gives me 365.8. So that means we need to walk 366 meters for the gradient to increase by a meter. Now grade 12s, the two examples that I've just done comes from a topographical map. What's going to happen if they're going to ask you the same question to go and calculate the gradient of a orthophoto map? Now I'm going to give you an example. If you look at number 2 over there, unfortunately it's a bit unclear over there. But let's state the question asks you, go and calculate the gradient along the line where number 2 is situated. So let's assume the contour line at number 2 is 1,000 meters. And the contour line on the other side is 400 meters. So I'm quickly gonna draw it for you over here. So I've just mentioned, let's try and replicate that diagram, the orthophoto. And there was a number 2. And let's say calculate the gradient from contour line that says 1,000 meters to the contour line that says 400 meters. Now what's going to change over here? Very importantly, grade 12s, we're using an orthophoto map with a different scale. Now, the formula stays exactly the same. Gradient equals the height over the distance. Now, to calculate the gradient from the contour line that represents 1,000 meters in altitude to the contour line that represents 400, what do? We subtract the highest from the lowest. And then we go and measure the distance from contour line 1,000 to contour line 400. You place your ruler between the areas. In this case, you can see it's 16 centimeters. But here's the catch. Because we're working off the orthophoto, what are we going to times the 16 with? 100. So if we could quickly get our calculator out and do the calculations, 1,000 subtracting 400 equals 600. Then 16 times 100 equals 1,600. Now remember, we need to get a ratio of 1. So we say 600 divided by 600 gives us a ratio of 1. And what we do on the top, we need to do on the bottom. 1,600 divided by 600. Let's quickly go and calculate it. It's 2,6. So that means for every 2,6 meters we walk, the gradient increases by a meter. That's all that we have time for today. Thank you for watching. I hope you've learned something and will be able to do these calculations in your final exam. I'll see you next time around. Thanks for watching.